Good afternoon, everyone. Welcome to IDAP 25 second keynote presentation session. I would like to sincerely thank Professor Dr. Ahmet Turan Özdemir on behalf of IDAP Organization Committee for accepting our invitation to serve as a keynote speaker for IDAP 25. Additionally, I want to express my gratitude to Professor Dr. Ahmet Turan Özdemir for his assistance in our IEEE application process for IEEE Turkey section support. In 2002, 2004, and 2010, respectively, Dr. Ahmet Turan Özdemir finished his undergraduate, graduate, and doctoral studies at Erciyes University's Department of Electronics Engineering. He was employed at the University Autonomous Undersea Vehicles Laboratory at the Massachusetts Institute of Technology, MIT, from 2007 to 2008. He was employed at the Department of Physics at Boğaziçi University from 2008 and 2009. He was a postdoctoral researcher at Bilkent University's Department of Electrical and Electronics Engineering from 2011 to 2012. He teaches in the Department of Electrical and Electronics Engineering at Kayseri Erciyes University. He serves as both the IEEE Turkey Vitality Coordinator and the President of the IEEE Aerospace and Electronics Systems Society, Turkey. Since September 13, 2023, Professor Özdemir has been the General Manager of the Aspilsans Energy Company Sector Working Group. He has a lot of achievements, and we don't have that much time to express all of the achievements of the Professor Ahmet Turan Özdemir. We will be listening to Professor Ahmet Turan Özdemir during this keynote session. Dear Professor Dr. Ahmet Turan Özdemir, the stage is yours now. You can begin your presentation.
I would like to express my good feeling to the organization committee of this conference and İnönü University. İnönü University is an important university in Turkey, and Malatya is my hometown, and this invitation is very important to me. And Aspilsans Energy, one of the important company over the world, and its specification is 44 years old, and it can produce cell-to-system battery. And we established in 1981 in Kayseri. At the beginning, we start to produce nickel-cadmium batteries. At that time, we have a factory in the first industrial zone in Kayseri, and then we expand our capabilities and start to produce lithium-ion battery in 2023 in Kayseri in our new factory. Next slide, please. And you can see our timeline. We first start to produce cylindrical nickel-cadmium batteries, and then after Cyprus war, we had some embargo as Turkey, and then we decided to produce our army electronics and other parts. And Aspilsans Energy, one of that company, was established in order to Turkish army critical battery needs. And we not only produce cell, but also radio batteries. And with the CASA project, we start to produce aviation batteries. And in 2005, we start to produce our own printed circuit board assembly line. And in 2015, we start over again to produce new technology cells like lithium-ion cells. in lab scale implementation was finished, and in 2002 we start to produce lithium-ion cells in mass production. And our company now produce torpedo batteries and aviation batteries, lithium-ion underwater or airway batteries, also space-grade batteries we are producing. And maybe we are one of the 5 over the world that can produce cell to system tech level company. As Aspilsan Energy, we have 3 main locations, Kayseri, Istanbul, and Ankara. In Kayseri, we have 2 factories. One of them is lithium-ion cell factory, and another one was nickel-cadmium railway system battery factory. And in Istanbul, we have sales department and international business department. In Ankara, we have R&D team, sales department, and some purchasing organization. In these 3 locations, Aspilsan Energy has employees over the Turkey. You can see on the slides, we have green factory. We produce our own energy from rooftop solar panels. Now you see some picture of our factory inside. This is NMC cylindrical cell factory. As I told at the beginning, our main focus on defense batteries. But in last 2 years, we expand our capabilities, railway system, naval system, aviation system, space system, electromobility, consumer electronics, and energy storage system. Energy storage system, consumer electronics, and space batteries are our new market expansions. As you know, there was a saying, world run on oil. This was very famous saying, and 100 years this was true. But now we are in new era, and we will say world run on battery, and world goes new era, and this era is battery and energy storage systems. Now China, maybe more than 75% of the battery production over the world belong to China itself. And raw materials also producing in China. And other parts, maybe other 20% is belong to Japan and South Korea. And Far East over the world is responsible to produce world batteries. Now in the Europe and United States, there is a huge incentives in order to produce battery locally. And Aspilsan is a unique company over the world. 44 years, we produce our own batteries with our own cells. And in 1981, we start to produce cell with German Warta. Now you can see on the page, we have more than 300 products in our portfolio. In the history, battery cell was the first sample in 1780s. Was a simple galvanic cells, and times goes up. In 2002, lithium-ion batteries start to producing in mass production. And first lithium-ion battery was produced in factory scales by Sony Murata, Japan Sony, but China now dominating the market. Next slide, please. And mostly in our conversation, we mention about cell, pack, battery, and system. As you say, single cell is consisting of simple cathode, anode, and separators with electrolyte. And when you combine cells, you can make a module with a battery management system. You can make your own battery, and this goes to battery systems. And battery systems can work underwater, on the sea, ground, or air, even space. And there are three different major batteries. These are cylindrical, prismatic, and pouch cells. Now there are blade batteries and some different batteries, but mostly these are belong to these three major geometry. This is the battery cell value chain. It starts from mining to recycling. And as Aspilsan Energy, you can see on yellow, from active materials to the battery pack, we can produce in-house. And Aspilsan Energy R&D capabilities covering much more than electrode to battery, because we have some R&D activities in order to produce active materials or our own recipes. And with Turkish universities and industry, we also working on recycling. And for independent value chain, the country has to complete this chain. Now, either European Union, and America, they have huge incentives in order to complete their chain. We can continue. Now you are going to see a video about our factory. As you see, our factory, we have raw materials, I mean active materials as powder. We have mixers we mixing our recipe with the proper combinations, and then we make electrode. After electrode, we have slitting machines, we have assembly machine. When we assemble our cells, you can see we can produce two different type of cells, 1865 and 21700. We complete all that process in our factory in-house, and from recipe to the battery pack, you saw our product portfolio. There are more than 300 different batteries. We use our own cell inside. This is the battery cell production map for the Asia. You can see on the map, except for forests, we are the only one producing in west side battery. And you see the battery value chain. And battery value chain, battery cell inside, cell, only cell, it has small percentage. And when you add value, when you want to make some value, you can, for example, some companies only producing cell and their product is only cell. If you make battery, you put more value to your product. And this is the value chain revenue forecast. And this is also covering recycling, recovering, mining process. Cell itself is very small percentage in the value chain. So this table is very important, and this can show both in industry and the universities. We know how much battery is important, but we may not know what percentage of value for the battery chain. And for researchers and industry, you can make some more research or investment on that area depending on this revenue forecast. And as you see, we can move on. Akif, we can move on. Move on. And as you see on the map from different producers or the market, each time when times goes, depending on the cell geometry, it's not only 1865, but also 21700. Energy density is rising up. Each year, the density of energy is going much higher than previous year. And in the future, we will see much more high density cells in the market. Because of this rising, usually cell producers also produce bigger size of the cells. For example, in the past, 1865 was the world standard, but people energy demand force companies to produce 21700. Now some factories produce 4665 cells, and this kind of cylindrical cells using in Tesla car batteries. Move on. And this is not a surprise. When you see global battery capacity report, China is number one. And China itself responsible the 77% of the total market. And it's interesting, Poland, they have huge incentives, and it's number 2. In the Europe, because of the localization, and USA because of the localization, too much investment migrating China to Europe and United States. And in our geography, there are huge potential to make battery investment. And the European market, as I told, there are huge incentives, and Northvolt itself gets 5 billion from European Union, $5 billion. Move on. And in the US market also, there are some new regulations. For example, in 2040, approximately 40% of the vehicle batteries planning to recover recycling from their old EV batteries. This is a target to themselves, because raw materials potential in United States is not much like China. Therefore, they do not allow to sell second-hand EV batteries to outside, but they plan to recover their batteries for future production. And as Aspilsan Energy, like battery giants, we have all necessary certification, like transportation, for example, UN 38.3, or for the United States, UL certification. We have all this certification from independent organizations like Kiva and others. We also have quality certification for military and other qualifications. And we produce nickel cadmium batteries for aviation, and for we have ESS, we had the ESA certification for European Civil Aviation certification, and we are able to producing batteries for Airbus, Boeing, Sikorsky. And railway system batteries, we are the only one railway system battery producer in Turkey, and we are the biggest railway system battery producer in Turkey. In every city, we have batteries in railway systems or electrical bus. You see some of our other qualification certifications. And in Turkey, there are some products. Our batteries using that platforms, for example, Turkish fighter jet Kaan and TUSAŞ, Turkish aviation helicopter projects, or Şurjet battery. These are all lithium-ion batteries. For example, Gökbey, Hürkuş. In Anka, we produce nickel cadmium batteries, and this year in 30,000 feet, our battery worked perfectly. And also in Turkey, we produce AUV batteries for different missions. Go on. For the marine projects, We produce Milgem, Barbaros, and other important platform batteries as nickel cadmium. We all produce mission critical batteries in Turkey. We also have very important capabilities. We can produce very high power EV batteries for the cars or the land systems. We also produce 6T battery. 6T battery is a kind of military system battery. We have that capabilities. Maybe there are 10 companies over the world can produce 6T battery. And we also have some other projects in order to produce submarine batteries. And in Turkey, on the Navy and maritime projects, we have new products, not only on the water, but also underwater, like torpedoes and other systems. These are some of our other projects for torpedoes. And for the space technology, we also produce some space-grade batteries. And now we have new critical MOU agreement with Turkish Aviation. And we plan to produce space-grade batteries for our space products. And now we are, as I start this presentation, now there is a new era. It's battery era, also storage era. For the sustainability and net zero targets, we need to store renewable energies, even solar, even wind energy. We have to store them. For the sustainable future, renewable energy has to be stored. And in our region, unfortunately, is earthquake region, and Malatya, Maraş, Adıyaman, 11 city affected by huge Kahramanmaraş earthquake, and our storage system supply many tent cities. And we show the importance of the storage system, and we will need this storage system in the future much more than before. For example, telecommunication system has to be suspended by storage system. And now Aspilsan Energy is ready to storage system. We have product from, it starts from 10 watts as a cell to 4 megawatt hours container. As you see, storage system is not only your cell phone or laptop or in the farm like solar storage system, but also in your home. As you see, these are home or office style storage system. We have also products in our portfolio. And as Aspilsan Energy, this year we start to sell our product to the civil with a Tetron brand, and we aim to bring our quality standards coming from army needs to civil needs. And you will see Aspilsan Energy products in the civil market much more than before for the next and other years. Thank you. for listening me.
Dear Professor Ahmet Turan Özdemir, thank you so much. Thanks for allocating your great time and sharing this great information with us. And I really appreciate for your time and effort. If our participants have any questions, please let us know, or you can write, you can type through the chat. And I would like to start with a question. Professor, you explained a lot of great tools and applications from our cell phones to the satellite. A lot of, tools are using batteries, and you are really doing a mission critical job and in the sector. Thank you so much for this. My question is, how, in this era of artificial intelligence, how do you apply artificial intelligence in your system, in your environment?
Yes, Arif Hocam, now I saw Mr. Teoman Hocam. Also, he is one of the participants for this event. And we have collaboration with universities and also our engineers. As you know, I am also academic people. We also work artificial intelligence. And for example, we use artificial intelligence for estimating state of health, state of charge, or troubleshoot. We use that tools in order to estimate battery health. And most of our products, they have algorithms. You can say artificial intelligence or statistical tools, but we use that tools in order to estimate battery, because the battery behavior changing chemistry to chemistry or application to application. Therefore, our capabilities comes from 44 years old, and we targeting to put our experience as artificial intelligence tools work on our battery management systems.
All right. Thank you so much, Professor. Any other questions for our speaker? And also, I would like to thank you, Associate Professor Teoman Karada. We also have been working with him on electrical vehicles. We have been doing some machine learning stuff to prediction and optimization in order to define, in order to estimate the amount of electrics are used or carbon dioxide amount that's saved from the environment. And any other questions? I think no one has question. Professor, thank you so much for your time. We really appreciate for your time and effort again. And thanks. And also, I would like to thank for all participants for this session. I say have a wonderful day, and this is the end of our session in IDAP 25 for this day. And tomorrow we are going to continue on 10 again. Thank you so much, and see you all tomorrow. Take care.